And these just give you lots of shortcuts for finding derivatives. And the first one, which many of you know already, is called the power rule. Okay? And what the power rule says is that if, I kind of got ahead of myself, but that's okay. If n is a positive integer, then d dx of x to the n is equal to n times x to the n minus 1. Okay? So, in other words, for the derivative, where you're raising a variable to a power, the equation of the derivative, all you have to do is take that power and move it in front, and then lower the exponent by 1 degree. So, for instance, d dx, which means take the derivative of x to the 4th power, what would that be equal to? 4x cubed. Okay? And that's all the power rule says. And we'll get to more complicated ones where you have to combine the power rule with something else. But right now, that's all the power rule says. And you can prove that by going through that whole limit process using variables and stuff like that. But the proof is actually pretty complicated. So if you're interested in that, you can look in the book because they do a proof of it. Okay? Derivative of a constant. Next thing. All you guys are signing up? I'm going to invite you. Okay, so you'll get an email from me that says you're invited to participate in Math Madness, and you either accept or don't accept it. Okay. Derivative of a constant. So d dx of c is equal to 0. So find the derivative. So for instance, find d dx or f prime of 5. What's f prime of 5? 0. And the reason, again, if you want to think about it, right, is because what the derivative is, it's the slope, right? And a line that looks like y equals 5 might be a line going across like that, right, at 5. What's the slope of that line? It has slope at 0. So wherever I go on that line, the slope is always equal to 0. So the rate of change is always 0. Questions about that? Easy, right? Rules. Okay. Constant multiple rule. So this is where you kind of combine the power rule with something else. So now you'll be great differentiators. When we get to the e to the x, we'll talk about the great differentiator because it's a good story. Okay. d dx of cu. Yay! Go cu. Sorry. Got carried away there. Is equal to c times d dx of u. And all that says is you can take the constant, if there's a constant in front of the variable, then you can pull that constant out in front and then take the derivative of the variable expression and multiply by the constant. For instance, if I have find f prime of of f of x, f prime, f of x equals 1/3 x to the 4th. Okay? So you'll get faster as you go along, but this is the same as what you want to do is 1/3 times the derivative of d dx, means the derivative of, with respect to x, of x to the 4th. So what is d dx of x to the 4th? What's it? We just did this in that little review.
4x cubed.
4x cubed. Thank you. 4x cubed. And so when you simplify this, you would get 4/3 x cubed. Now, as you become good at differentiating, all you have to do is say, oh, I just multiply this times this and lower the exponent by 1, right? So the derivative of 1/3 x to the 4th would be 4 times 1/3 x to the 3rd. Questions? We're good with that? Easy, right? Isn't this better than doing limits? Yeah. Okay. Yeah. See, you're glad you learned the limit process because this makes you appreciate how easy it can be, or something like that.
Mr. Leader, I think everyone signed up.
Everyone is signing
I
up.
mean, not everyone signed up. Everyone
No, let's go.
Are you up? Guys, are y'all really gonna come?
Call me
I mean, I can't for the first couple. Yeah, we have
Cross country. Some and difference. Difference rule. Okay. So d dx, d, and I try to come up with my own examples rather than the ones in the book. U plus or minus v is equal to the derivative of u plus the derivative with respect to x of v. So for instance, if you have a polynomial function, find losing my voice already. Find y prime for y equals 3x squared minus 3x plus 5. I can break this into 3 separate derivatives. So y prime, what's the derivative of this?
6x.
6x. Does everyone see where we got 6x? 2 times 3, lower it by 1. What's the derivative of negative 3x? Negative 3. And what's the derivative of 5? 0. So that's your derivative. Okay? Yes. Okay. So for those of you in the viewing audience who aren't here, I just told people how to find the horizontal tangent. You set the derivative equal to 0. And I found the x coordinate and the y coordinate. There you go. Moving on. Now we're going to learn about something that you that you probably haven't heard of before. And this is called the product rule. Anyone hear of the product rule? Okay. So this is how the product rule works. D dx of u dot v, which are two functions, okay, equals u dot dv dx plus v dot du dx. What does that mean? That means if you have a function which is the product of two functions. For instance, f of x equals, x cubed minus 2x times x squared plus 4. Now what you could do, if you didn't know the product rule, is multiply this mess together and then take the derivative of it, right? But if you know the product rule, you don't have to multiply it together. You use this rule. So what this says is this is u and this is v. Got it? And so what you do is you leave u alone. So f prime of x, this says leave you alone. So why don't you just leave me alone? Well, okay, leave u alone. X cubed minus 2x times the derivative of v with respect to x. What's the derivative of v with respect to x? So 2x, okay? Plus v left alone times the derivative of u with respect to x. So v left alone is x squared plus 4 times du dx, which is what? 3x squared minus 2. And then you would want to simplify that. Okay, so f prime of x, you need to multiply this times this, you get 2x to the 4th minus 4x squared plus, then you have to FOIL this. So what's the difference if I FOIL this first and then took the derivative? Because a lot of times you get functions that are not all polynomials, like derivative of e v x or natural log of x or stuff like that, which we don't know how to take the derivative of yet. And you wouldn't be able to multiply them together and then take the derivative. You see, so that's why, even though these are all polynomial functions, they won't always be. Okay. So this times this gives you 3x to the 4th. Did I do that right? First, outer gives you minus 2x squared. Inner gives you plus 12x squared. And last gives you minus 8. And then you combine like terms. So I have 2x to the 4th and 3x to the 4th, 5x to the 4th. And then you have a bunch of x squareds. Minus 4 minus 2 makes minus 6. Plus 12 makes plus 6x squared. Tell me if I make a mistake, because I have made a mistake before. Minus 8. I think that's right. Let me check. Did I do it wrong? It's what? What? Who?
I'm trying to figure out if that would really be.
If you have something like x squared plus 2x times e to the x, right? Then it would be, because we don't know how to differentiate e to the x yet. We will, okay? But here you don't want to distribute it and then distribute that, because then you're going to have to use the product rule twice versus so
We're not
that
supposed to know how to do that yet, are we?
e to the x?
Yeah.
No, we don't know how to do that. We'll learn. I have this chapter and next. Okay, it's pretty easy. Okay, so that's the product rule, and I got that right. Okay, couple more things. The next thing is called the quotient rule. After products come quotients, right? So let's see if I can hide this, because it's in the way. The quotient rule. And if you're interested in where these all come from, you can look at the derivative how they're proven in the book. Okay, equals v du dx minus u dv dx over v squared. Okay? What the heck does that mean? That means if you have a quotient. For example, say I have f of x equals x squared minus 1 times x squared plus 1. And I want to find f prime of x. Okay, so what this is I take, so this is, sorry, the bottom function is b, and the top function is u. Okay, so what it says is take the bottom function times the derivative of the top, bottom d top minus top d bottom over bottom squared. Okay, and there's various acronyms or little rhymes that you can make up to help you remember. Okay, but I think it's like d top minus top d. I don't know. You can look it up on the internet. But there's all kinds of clever ways that people remember it. But so in order to do this, I'm going to take the top, leave that alone, x squared plus, I mean the bottom, sorry, x squared plus 1, times the derivative of the top. What's the derivative of the top? 2x, okay, minus, excuse me, the top left alone, x squared minus 1 times the derivative of the bottom. What's the derivative of the bottom? It's also 2x over the bottom squared. So that's x squared plus 1 squared, like that. And then if then I want to simplify. Let's change colors. Okay, f prime of x equals, and then things will usually simplify pretty nicely. 2x cubed plus 2x minus, and be careful with your signs here, 2x cubed minus 2x over, sorry about this squishy line, x squared plus 1 squared. And notice that I have a 2x cubed, which goes away with that 2x cubed, and I have 2x minus 2x, which makes how many x? 4x over x squared plus 1 squared. Okay, so that would be the derivative of that. And what? Is that what?
Do we simplify the denominator?
No, you can just leave it just like that. You don't need to multiply it out. Okay, so it's just kind of algebraic method. So this would tell you, excuse me, this would tell you the slope at any point of this rational function. So it's kind of similar to it, but not exactly the same. Now, another thing, whoops, that you might see is numerical problems with quotient rule, with the product or quotient rule, and these are good ones because these ones also come up on the AP test and on our tests. And this book is good at throwing in things that are AP-ish. So, say for example, you are given something like this. If f of u, no, I didn't say a bad word. If f of u, no, that's wrong. If, not f of u, sorry. If u of 5 equals 3, and u prime of 5 equals 1, and v of 5 equals -1, and v prime of 5 equals 2. Find the derivative of u over v. So these are nice problems because they're just testing if you know the product rule, I mean the quotient rule, but it's really easy to do, the math is really easy, okay? So another way the quotient rule can be written is like this. Y prime is equal to B U prime minus U B prime over B squared, right? The bottom left alone times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, okay? And so all you have to do is take these numbers. So what's B? -1, so you just plug into this into here. So -1 times U prime, which they tell you is +1, minus U, which is, I should have said at 5, sorry. At 5, because this is the derivative at a specific point. Okay? So -1 times 1, U is 3. B prime is 2. And B squared is -1 squared. And then I just do the math, which is -1 minus 6 over 1, which is -7, right? -7. See? And sometimes I'll give you like a table. They'll say U is this, B is this, and I'll give you a little table, and they want you to find the product, the quotient, the this, the that, the U over B, B over U, U times B, B times U, U plus B, and all that kind of stuff. And that's kind of what you do in that. Okay, last thing. Yay! Good. And this is higher order derivatives. Oh, no, sorry, there's 2 more things. I'm sorry. Darn. Okay. Did I pause my thing? No, are we still recording?
I don't think so.
Let me see. Time's still going. 23 minutes. Come on. We're doing fine. Power rule with negative integers. What if you have something like could you do that? Could you do that?
Yeah.
Could you do that? Brandon?
Oh, no.
Okay, so now I have a negative exponent. So this is the same as f of x is equal to 2 over x to the third, right? But so you can do this a number of ways. You can rewrite it like this and then apply the quotient rule, okay, which is probably not what you want to do, because then you got to do like 4 different derivatives, or 2 different derivatives, and simplify all that. All you really have to do is it works, the power rule works for negative exponents as well. So what would f prime of x look like? Negative 6x to the what? No, not to the -2. Negative 4, because this goes down by 1, okay? And so people get confused with that, because that exponent goes down, it doesn't go up to -2, right? It goes down to -4, which is the same as -6 over x to the 4th power, right? So that's the derivative of that. And then at x equals 1, what's the slope? -6, right? And then to find the equation of the tangent line, y minus y1 equals m times x minus x1. And some of you left your answers on the test in point slope form, which is just fine, okay? So y minus y1. How do I find y1? Where do I plug it into? Into the original equation. That's a mistake that people make all the time. They plug x into the derivative equation, not into the original equation, because you're going to find a point where the slope is -6, or the slope and the y value. So if I plug in 1 in here, what do I get out? If I plug in 1, f of 1 is 2. Okay? So I get y minus 2 equals -6 times x minus 1. Right? And then y, I'm just going to put this in point slope form, because even though you don't have to do it, because I want to show you graphically. -6 times 6 times 1 is +6, plus 2 makes 8. So watch. If I were to graph this, I want to show you graphically that this works. Go ahead. Tessa. So, I didn't mess up, did I? Oh yeah, I didn't mess up. Okay, so y equals 2 over x cubed. I'm going to plug it in there. 2 divided by x raised to the 3rd power. Right? If they say confirm graphically, this is what they mean. And then I'm going to put y equals -6x plus 8. I'm going to put in a standard viewing window, which is, let's do zoom 6. Is that zoom? Yeah. Zoom 6. And whoops, I did box. There you go. So there's the curve, and there's the tangent line at 1, and you can see that it actually hits that. Hits that and just exactly goes through that spot. So what I found is the function, and then the tangent line that goes through that function, or just exactly hits that point, and right there. Okay? Questions on that? Okay, very last thing, I promise. Very last thing. And this is easy. Higher order derivatives. So let's see. Have you guys seen this? D equals 1/2. What is it? Was it like 9.8 t squared plus? You guys remember this? I don't know. The distance, velocity, and acceleration equations for physics. I should have thought about that before. But distance, what's the rate of change of distance? Right? Distance over time, the instantaneous rate of change of distance over time is what? Velocity. And what's the instantaneous rate of change of velocity over time? Acceleration. So if you take the derivative of a distance equation, that'll give you the velocity equation. If you take the derivative of the velocity equation, that's going to give you the acceleration equation. That's the next section. Okay, but that's part of why you want to learn this. So higher power derivatives are just taking a derivative of a derivative. So for instance, say I have y equals x to the 5th minus 3x to the 4th plus 2x plus 1. And they say first they want you to find y prime. And that's going to be, you guys can do this for me. What is it? 5x to the 4th minus 12x to the 3rd plus 2. Now they want to find, oops, 5x to the third, sorry, right?
5x to the fourth.
Sorry. 5x to the fourth, okay? Minus 12x cubed plus 2. Now I want to find y. Sometimes I write it as y double prime, or they'll write it like this. D squared y dx squared. Okay, that means the derivative of y with respect to x, the second one. So what's that going to be? 20x cubed minus 36x. And you could keep going, whoops, 36x. And you could keep x squared, sorry. And you could keep going until you end up with a constant. What's y triple prime? 60x squared, what?
36x.
Minus 36x. What's 72x? Sorry. 72x. What's y quadruple prime? The fourth derivative. 120x minus 72. You can keep going. You can find the fifth derivative and the sixth derivative, okay, until you get to 0, right? Because you can take the derivative of a constant. And that has applications in life when you get into space, because you're dealing with functions in 3 dimensions and all that kind of stuff. So, and like I said, in distance and speed acceleration. So that's about it. Remember, you have heard it here on my Cutting Edge YouTube channel. And your homework is, I'm going to write that right here. Okay, so that's your homework. Page 124, 3 through 45, multiples of 3, so not that bad. That means like 3, 6, 9, you know that, 3, 6, 9, 12, until you get to 45. 46 and 47 are some problems I picked out, and then 50 through 58 are multiple choice, like AP type problems, okay? So you can start, and I'm done.